Hello and welcome to this section in further maths. Today we'll be talking about moment of a force. But before that, let's take a quick preview of our previous lesson. Welcome back. What is moment? Moment of a force. The moment of a force about a reference point is defined as a product of the force and the force arm. So the force times distance. Moment of a force is a vector quantity because it talks about force and the distance of the force. The direction of movement or sense of moment about the point is duly considered. Now, for example, let's check the basic principles of moment. But when a system of coplanar force, coplanar, that is double forces, is in equilibrium, then the sum of the clockwise moment is equal to the sum of the anti-clockwise moment about the same point in the plane. Now, what this is trying to say is that when you have, let me say, a knife edge, a triangle, with a straight rule at the top, if a force acts in this direction to bring this down, and another force is acting in this direction, you know, when this force acts here, this side is supposed to go up. So, and this other one is acting down, is projecting this to go up. Now, it's trying to tell us that about this point, the sum of the clockwise direction is equal to the sum of the anti-clockwise direction. And with that, this will rest perfectly on this point. So, at this point, if this is 20 kg and this is the middle of it, this is supposed to be 20 kg, so that the resolution, you resolve the total moment, your answer will be 0, because the sum of the clockwise is equal to the sum of the anti-clockwise. So the resultant force on this ruler becomes 0, then the ruler can be suspended freely without falling. Now, when the system is not in equilibrium, then the resultant of two coplanar forces, F1 and F2, is represented by the relation below. Where M1 is a moment of F1, M2 moment of F2, and M3 moment of F3. Now let's try this and round up with it. Now a uniform beam AB. Now we have to draw it. Just like what I explained about a moment A and B of length 6 meters. So from here to here is 6 meters. Had a mass of 20 kilograms. So this is the middle. Let's call it 20 kilogram. Rest on the support P and Q placed 1 meter from each end of the beam. Okay. Masses of 10 kilogram and 8 are placed at A and B respectively. So we have 10 kilogram. And this point is 8 kilogram. I place at their respective. Calculate the reaction at P and reaction at Q. Now let reaction at P. Let reaction at P be equal to reaction at P, and that of Q be equal to reaction at Q. Now we have reaction at P, we have R at Q, moment about Q is RP times 4, which is equal to 10 times 9.8, which is acceleration due to gravity. For the first one, that's 10 times 5 plus, we now have 20, that's the second force, about A2, 20 times 9.8 times 2, then plus, what's the last force? This is 8. This is 8 times 9.8. So this is just times 1. So with this, we have 4RP, which is equal to 490 plus, this is 392 minus, okay, this is 390 because it's a clockwise movement. This is minus 78.4. So the value here is 803.6. Then RP, reaction at P, is 803.6 divided by 4. So RP is 200.9 Newton. That's for this. Now we also have to calculate the moment about P. So that one we call it RQ times 4 is equal to the same thing we did here. So we start with, now about this has a positive sign, 8 times 9.8 times 5, because then the next one now will be plus 20 times 9.8 times 2, and minus, because now we are talking about the 10 kilogram, minus 10 times 9.8 times 1. So our 4RQ will now be equal to 392 plus 392 minus 98, which is equal to 689. So our value of RQ is 689 over 4, which is equal to 171.5 Newton. So when the reaction, because the question is calculate the reactions at P and Q. So the reaction at reaction P, that's moment about Q, is equal to 200.9 Newton, and the reaction at Q, that is moment about P, is equal to 171.5 Newton. Thank you for being part of this lesson. I would like you to take the test that will be popping up very soon from this screen. Always do well to consult this material or the platform for better understanding on any topic. Thanks, and see you in our next lesson.